Let's do a very basic calculation. What we will do is look at the mass of a fluorine atom. What's the mass of the fluorine atom? Well, where do you look for the mass of the fluorine atom? And what will be the units of that mass? You will look it up on the periodic table. Under F for fluorine. Fluorine has the atomic number 9. So search for fluorine on the periodic table. And when you look at the mass, you will see that it says 19.00 AMU. So what is the atomic mass of one atom of fluorine? The answer is 19.00 AMU. And that's very basic. We can do this with any atom. But I want you to convert that mass to grams. What's the mass of one atom of fluorine, not in AMU, but in grams? What will you do? How will you find that out? From our previous experiences in chapter 1, in order to do any conversion, we needed conversion factors. And we came up with conversion factors using relationships, such as 1000 gram equals 1 kilogram. Once we know that, we can interconvert between grams and kilograms. So here I have the mass in AMU and I want the same mass in grams. So what's the relationship between AMU and grams? Have we looked at that? Yes, in the previous video we just did that. 1 AMU equals 1.661 times 10 to the negative 24 grams. So we have that relationship, and based on this relation, what is the conversion factor? Basically, the conversion factor is writing one of the terms on one side as a numerator, 1 AMU over 1.661 times 10 to the negative 24 grams, or flipping it and seeing which one is going to help us to cancel out the units to get us the right unit we want. In this problem, we want to find the mass of one atom of fluorine in grams. So 19.00 AMU is the mass of one atom of fluorine. Okay, 19.00 AMU is the mass of one atom of fluorine. Please, when you do these calculations on a piece of paper, write down the identity of the atom. Don't just write down 19.00 AMU over one atom, because this pertains only to fluorine. Some other atom may have a different mass, and later on in your calculations you may have to keep track of which atom you are talking about. Okay, so that's the mass of one atom of fluorine. Now we will multiply it with our relationship from the previous slide, where we saw that 1 AMU equals 1.661 times 10 to the negative 24 grams. Now notice how the 1.661 times 10 to the negative 24 grams is in the numerator. Why? Because we want the AMU of fluorine to cancel out on both sides, so we put it in this order. AMU of F and AMU of F both cancels out, and then what remains? What are the units that remain? Grams divided by atoms of fluorine. So we find out the mass of one atom of fluorine in grams as 3.156 times 10 to the negative 23 grams. It's very small. And please look at this problem in order to solve for this and similar problems which you will see in homeworks and exams, where you are given the mass in AMUs and you have to find the mass in grams. Or vice versa, you may be given the mass in grams such as this and be asked to find the mass in AMUs. All you have to do is flip the conversion factor and you will see how you would be able to know the number of AMUs in that case. But as you notice here on the right side, this mass is very tiny, and you would expect this to be very tiny. It's 100 million quadrillionth of a gram, 3.156 millionth quadrillionth of a gram, a very small mass. You cannot measure this mass in the lab, and if you were to do some chemistry in the lab, whatever amount you pick up of fluorine is going to be more than that small amount. So how do we work with larger amounts? what do we do when we have no choice but the amount of grams will be greater than that? Well, we have defined a special new unit called the mole in order to work with larger amounts, more practical amounts. The mole is a counting unit. If I say a dozen, what comes to your mind? That's right, 12. If I say century, what comes to your mind? 100. A pair, what is a pair? 2. A pair of anything is always 2, whether a pair of shoes, a pair of soda cans, or anything. Similarly, the mole is also a counting unit. Pair is a counting unit, a dozen is a counting unit, and so on. A mole is also a counting unit. But in the mole, you have not 1, not 2, not 3, but 6.022 times 10 to the 23. That's the number of individual units you have within a mole. And because the mole pertains mostly to chemistry, in chemistry we are counting atoms. That's why it says 1 mole of atoms equals 6.022 times 10 to the 23 atoms. But what if you had 1 mole of human beings? 1 mole of human beings will equal to 6.022 times 10 to the 23 human beings, a very, very large amount that cannot be fit in the earth. But when it comes to the mole, this number, this quantity is the total number of atoms, and because atoms are very small, we are now approaching amount that is actually something that we can work with in a lab. Okay, when you take a teaspoon of some substance and you were to count the total number of atoms, well, they would be just too many to count. But if you were to express them in moles, it would fall somewhere where it's practical. So anywhere, if I had to come up with some value, anywhere from 0.1 mole or smaller, that's actually measurable, to 10 moles, for example. Okay. Now in a dozen, you have 1 dozen, you have half a dozen, you have a quarter dozen. That's how we work with dozen. If you go to the supermarket, you can buy 4 eggs, which is, or 3 eggs, which is a quarter dozen, or half a dozen, which is 6 eggs. With a mole, you can have 1 mole, you can have half a mole, but then you can have 0.057 mole, 0.129 moles. So with the mole, we have more flexibility. We can take a smaller fraction, smaller than 1, and we can take any number. Okay, but the mole makes our life easy. Now this number, 1 mole equals 6.022 times 10 to the 23. This number is known as Avogadro's number. It's named after the Italian scientist Amadeo Avogadro, who discovered this number in his scientific research. Okay, that's why it's named after him, Avogadro's number. It's a very important number, and this is one value I want you guys to memorize: 6.022 times 10 to the 23. That's Avogadro's number. Back then they didn't have 4 numbers, but you may have seen a lot of funny expressions of what's Avogadro's number. Well, it's 6.022 times 10 to the 23. Okay. So that's the mole, and as I said, a mole is a counting unit. Mole is spelled out as MOLE, but the abbreviation of that is MOL, just removing the one E from the end. In the next video, we are going to do a problem. We'll solve a problem as we convert AMUs to grams and also moles, and we'll see how it makes our life a lot easier when we carry out work in a lab.